Good morning, we are team number 1, and this is our final project where we are going to be talking about our analysis of a scientific article from the PIA program. My name is Javier Barrios Puente, and I'm going to be starting off with the objective of this presentation. The article titled Case Study on the Improvement of Key Indicators in an Assembly Process Using the Line Balancing Tool aims to demonstrate how the application of line balancing techniques can improve key performance indicators, also known as KPIs, in an industrial assembly process. Specifically though, the main objective is to apply the line balancing tool to enhance production efficiency, reduce operational times, and optimize labor distribution in the manual assembly process of a portable fan. Through this objective, the article seeks to provide a structured methodology that combines theoretical knowledge and practical implementation to solve real-world industrial inefficiencies.
Well, as introduction for us, it's very important to mention that productivity in production processes is one of the key factors for its competitiveness, and it's based on the optimal use of resources used in the processes. To establish the SMART objectives, that this means specific, measurable, achievable, relevant, and timely, and clear goals are used. Staff performance and engagement improve significantly, and this is achieved through the monitoring of key indicators. Line balancing techniques focus on the design of these resources, minimizing idle time and adjusting workstations and operators to the required cycle time. But well, now if we talk about the description of this method, that it's based on the scientific article that we investigated. First, we like to mention that the implementation of the line balancing proposal using the statistical and graphical method was developed based on the practical experience of the teaching activity conducted jointly with industrial engineering students. And well, this proposal were developed during the assembling of the process of a handheld, which is made of 13 components. But well, to develop the educational activity and prepare balancing proposal, a team of 6 members was created. And well, in this team of 6 members, there were rules, and there were rules of operators and roles of analysts. And well, to make this selection, a learning percentage assessment was conducted. And well, by doing that, the operators were the ones that were responsible for making all the process of the assembling, and all the analysts were the ones that were responsible for taking all the information from this process. And well, once this assignment was completed, the standard time for each of the workstations for which the operators are responsible was calculated. They provides a current scenario for developing improvement proposal based on the balancing technique. And well, the training activity was carried out with 3 stages, that are the process measurement study, the proposal for improvement, and the experimental simulation, that these are going to be now explained by my partners. Thank you.
Continuing with the process measurement study, in this first stage, the learning percentage of the operators responsible for carrying out the assembly process was determined, and information on the assembly process time was also recorded to calculate the standard time. To do this, the initial proposal was to perform the assembly at 5 workstations with 1 operator at each station. Therefore, there is only 1 analyst. The learning percentage allows you to determine whether a given operator has the necessary skills to perform a specific process and to establish a standard time. Now with the key steps of the process measurement study. First, we have the task breakdown, where the assembly process is divided into individual work elements. Second, we have the time study, where observed and recorded task times using stopwatch method is used. Third, we have the learning curve adjustment, where operator efficiency over time was considered. Fourth, we have the allowances added, including time for fatigue, personal needs, and delays to calculate standard time. Fifth, we have the line balancing proposal, where tasks were redistributed across workstations to reduce idle time and balance workload. And finally, we have the performance improvement, where our cycle time went down by a 37%, our lot time by a 29%, and our production index went up by a 42%.
Hi, my name is Amelie Cantu, and I'm going to talk about the proposals for improvement. The improvement proposals focus on a balanced assignment of tasks to each station, ensuring the assembly process is carried out with the least possible downtime and avoiding inventory buildup. To this end, in this second stage, we propose implementing a line balancing method using both the statistical and graphical methods. The statistical method establishes an actual number of operators per station based on the original assembly distribution, achieving a balance time using the longest delay determined by the bottleneck station on the assembly line as a reference.
Hello, my name is Luis Angel, and I'm going to explain the simulation the article will investigate, which practitioner says. In this final stage, a simulation was developed. The educational simulation consists on performing the fan assembly process on the conveyor belt, whose speed is determined by this process cycle time. Workstations are set up around the conveyor belt, according to the layout determined by each balancing method developed. The developer operates under the command of the programmable logic controller (PLC). Each time the process cycle time is completed, the motor is automatically activated and remains in that state for the travel time spaced according to the distance between station and assembly requirements. During the simulation, operators perform the assembly while analysts monitor case process indicators.
So, in conclusion, the implementation of balancing techniques demonstrates that it is possible to operate all workstations simultaneously, reducing idle time between stations and reducing inventory accumulation. A comparison of the application of both balancing methods on the same assembly line shows how the efficiency of the line can be improved with proper task assignment at each station. It is worth mentioning that the learning rate of the operators at each station is crucial for achieving efficient line balancing. Thank you for your attention.